Good morning, everyone. Good evening and good afternoon. My name is Joy Johnson, and I'm the President and Vice Chancellor of Simon Fraser University in Vancouver, Canada. Welcome to our panel, Marshalling Global Research Infrastructure to Address Emergencies, Incorporating Resilience and Agility in Research Infrastructure Planning, Financing, and Operations. We have a fantastic panel with us today, and I'm going to just briefly introduce all of them to you. We have Dr. Barcon. Dr. Barcon has been the European Southern Observatory Director General since 2017. We have Dr. Kuch. Dr. Kuch is the Director General of the Integrated Carbon Observation System, and he's been in that role since March of 2014. We have Dr. Morris with us today. Dr. Morris is the Director General of the Terrestrial Ecosystem Research Network. And finally, last but not least, we have Ms. Panagopoulou, who is the European Research Area Innovation Director with the Director General for Research and Innovation with the European Union. Welcome to all of you. It's great to have all of you with us today. The bios for our panelists, more detailed bios are available. So let's get started. And I'm going to just ask you to begin with, those of you who are with major infrastructure projects, just to briefly tell us a little bit about your infrastructure and maybe a challenge or two that you've experienced in the last year and a bit with the pandemic. And I'm going to start with you, Dr. Barcon.
Yes, thank you very much, Joy. We at the European Southern Observatory, we are an intergovernmental organization, and we build and operate large astronomical telescopes in the ground for more than 50 years now. So we are actually operating for the benefit of the community some of the most powerful instruments like the Very Large Telescope, ALMA, together with our international partners, and also building new big facilities like the Extremely Large Telescope. This year has been especially challenging, as you can all imagine. We had to try to make progress in our projects without being able to travel, without being able to have everyone on site, with industry being also in trouble with some limitations, and still operate our facilities, delivering data to the scientists, which we could do at least during a good part of the year. So yes, overall very challenging, but also with lots of lessons learned, I would say.
Thank you. Dr. Kuch.
Well, ICOS is a distributed research infrastructure. You can see the network behind me. And we have invested a lot in concrete and steel, but not in one place. It's distributed over 13 European countries. And we are observing greenhouse gases. So we are measuring, for example, the fluxes between natural ecosystems and the atmosphere. And this brings us, of course, very closely to the societal challenge of climate change. We are not only working in ecosystems, we are also measuring the fluxes between the oceans and the atmosphere, and we are doing direct measurements of the concentration in the atmosphere. But it's not only about concrete and steel, it's also about a very nice community of technicians and of scientists who maintain the station, but also use the data and provide knowledge to the society, for example, to the IPCC or to the UN Climate Convention. And luckily, we have a lot of automated systems, so we came quite well through the crisis and to the shutdown. And interestingly, we also could measure some of the impacts of the shutdown on mainly on the fluxes. It has not so much influenced the concentration in the atmosphere of greenhouse gases.
Thank you very much. Dr. Morris, I see an image that's similar to one that's behind you. Why don't you tell us a little bit about your infrastructure?
Thanks, Joy. Yes, TERN is the Australian continent's ecosystem research infrastructure. So we do some carbon monitoring, but we also do a whole range of other things. So We've been in existence since 2009, funded by the Australian government to do the whole of the Australian continent and provide that from the Southern Hemisphere into all the global collections of data about what's happening in the environment. So we have remote sensing, and we have about 800 sites across the country that we do time series surveys at, and we have 15 really highly instrumented sites from which we can work out what's actually happening, what processes are happening in the ecosystem. And COVID happened very quickly after Australia had some devastating widespread bushfires, and TURN was hoping to be able to do a lot of work in the field monitoring recovery and effects of bushfire on our ecosystems and biodiversity. But with lockdown, as has been mentioned by others, it was not possible to get into the field, and was also exacerbated by the effect of the bushfires. Some of the sites were just too dangerous to go to, with trees still, falling and things like that. And we managed to run everything that was instrumented continuously as we normally do, but things that relied upon our field crews being out and about maintaining equipment and gathering data were severely affected.
Thank you very much. So we've heard about 3 really interesting large infrastructure, scientific infrastructures, and I'm going to ask you a first question, Ms. Kanagopoulou. I'm wondering if you can maybe talk a little bit, as a funder, what do you see as the key ingredients for these partnered arrangements across countries? I can't hear you. You are on mute, Ms. Kanagopoulou.
Sorry, yes, is the keywords of the last year. You are muted. So thank you very much for the invitation. Very happy to be with you today. So in the European Commission, we have a lot of experience on not only funding research infrastructures, but pulling together collaboration between different research infrastructures across Europe and beyond. So the main ingredient for having pulling research infrastructures together is, first of all, to establish an international collaboration about specific themes and areas. Second, to align the priorities among who should be those infrastructures to be considered as the ones where public investments coming from the European level, but also a national level, could contribute to. Create incentives for establishing international or bodies where different distributed infrastructures could collaborate between them, and as well as create incentives for utilizing the data, the results of the research infrastructures, but also providing access for scientists to those research infrastructures, so that the outcome of this collaboration will be beneficial, not only for the infrastructure itself, all the network infrastructures, but also for the European society and the Europe in general and beyond. So in this context, I would like also to highlight that in the context of the pandemic, we put in place a new platform, the European COVID-19 data platform, in a very short time, on a basis of existing infrastructures, in order to collect data that are related to the pandemic. And I'm happy to announce that we have by now, in less than a year, 114,000 users and 3.6 million web requests over 170 countries, which demonstrates that collaboration between different infrastructures at international level and will provide data that are very important for the public needs. So that's my short intervention.
Thank you very much. I'm just wondering, on the ground, so we've heard a little bit about some of the key ingredients. I'm wondering if there are other ingredients on the ground in terms of this kind of coordination. What is the magic behind this partnership? Dr. Barkan, do you have anything else to add in terms of what you see as key ingredients?
Well, yes, but I think I agree with what has been said so far. I mean, we were born international, right? I mean, we have 16 member states today, and actually we are part of a bigger project, which is called ALMA, and there we're partnering with the United States, with Canada, with Japan, Taiwan, South Korea. So it all gets really global when you try to put together an infrastructure that it's powerful enough to meet the requirements from science, from society in any respect. Then the trick, of course, is to get the right governance model for these things. And this is not always particularly easy. Our experience being an intergovernmental organization on our own, that has been incredibly helpful. We can plan, we can develop long-term projects. We know, to a high level of precision, the funding that we will have for them in 10 years from now. And those things are really the basic ingredients. Of course, the challenge is to get everyone behind the same project. And this is super important, I would say.
Dr. Morris, I see you nodding along there in terms of both governance, but also alignment.
Yes, exactly. Both Dr. Kusch, Werner from ICOS, and myself in turn have had the pleasure over the last few years of putting together a global ecosystem research infrastructure, which combines the efforts of Australia, South Africa, China, the US and Europe in forming a global group. And the key ingredient there was, first of all, working out how we would structure the governance to sort out all the issues of how we would communicate, sort out any, resolve any conflicts, and exactly what we would do together in that environment of what we call GERI or GERI, depending on who's pronouncing it, Global Ecosystem Research Infrastructure. And so I think it's been a really good structure to make sure that there is harmony across all of the continental scale observatories of the world to be monitoring some common parameters so that we add some great benefits to groups that have to make global type decisions about how the environment is tracking, particularly in times of crisis.
Mm. And Dr. Kusch, I see the diagram up behind you of all the partners involved. I'm wondering, do you think right now, are you seeing any more openness to these types of collaboration? I'm curious about that.
Oh, definitely there will be some openness. Let me perhaps first say that, seeing this map of these different infrastructures and all the stations, of course, is giving some challenges. The motivation for that is, of course, that climate change, greenhouse gases, and any other environmental problems usually are not stopping at national borders or between continents. They are global, and that's why we need also in our science a global answer. But this brings also some challenges. Dr. Morris already mentioned the governance, but it's also very important that we have, for example, standardization between the observations. That's something that we are longing for, that we are not comparing apples and oranges between the different networks. And you can see there are huge gaps between the networks. Europe is very concentrated with the stations, and between the European and the South African partner, there is a big gap over the African continent. You can also see behind me that there is not much in South America. Central Asia is missing, and so on and so on. So definitely we are open to connect to these regions, to research organizations, to research infrastructures in these regions. But we are also open to support these regions to build up infrastructure in case this is not there at the moment.
That's interesting. Not every country obviously has access to funds to build infrastructure to be part of these kinds of networks. And I'm just wondering, and maybe I'll go to you, Ms. Panagopoulou, what in your view, what are some of the ways that we might be able to involve countries in this type of infrastructure when they do not have the funds? Is there a role for these countries to play? And you're on mute. Oh, yeah.
Yes. Yes, thank you. First of all, I would like to say that being possible to accommodate the needs of developed nations and integrate them in the network of research infrastructures is clearly one of the priorities that we look in the European research and innovation policy, and in particular on the context of the next framework program, Horizon Europe. As it was said, the global challenges are global challenges, and there are no borders between Europe and the developed countries. So it is extremely important that we involve countries such as Africa. And for this reason, the European Commission plans to fund a bi-regional initiative with Africa on greenhouse gas observation, for example. And we have seen concrete priorities in the context of the new calls under Horizon Europe program for research infrastructures. Distributed research infrastructures in this sense are opening up new opportunities for cooperation that didn't exist before. But also, what was said by Mr. Kuch, it's a matter of trainings, providing support and educate those scientists from the developed countries in order to be able, once they participate in the network, to run activities in their own research infrastructure. So this is something that also we see that we have to, and we do need to finance with the support of scientists and research infrastructures that are well developed and established in Europe and beyond in the context of international cooperation.
Thank you for that. Dr. Barkan, are you involving scientists from countries that might not have infrastructure? Do you see ways to involve them in the science that's evolving with, I'm going to start that question again. Dr. Barkan, I'm wondering if you see ways that you can involve scientists internationally, particularly from countries that might not have the funds for this type of infrastructure.
So yeah, I think there's two aspects and two answers to this question. One is on the usage of the data that the research infrastructures obtain with a lot of effort. On this topic, there's now a wave of open data access all around the world, which, I mean, we in astronomy and in space sciences, we had already put together 40 years ago by making all the data available to everyone openly in our archives together with the tools to deal with them. This is extremely important. This is the tool that you need to train the new generations of scientists, the young people in all the countries, not just in the developed ones, not even in the owners of the infrastructure, because the data ends up being accessible to everyone. So that's one aspect that we need to cultivate and keep working on it. A different one is how to help to develop the infrastructures themselves. I'm sitting with a nice picture in my background. This is the Very Large Telescope. This is in Cerro Paranal in the Atacama Desert in Chile. This is a facility, this is a very powerful astronomical observatory that our organization built 25 years ago. It's the most powerful telescope in the world, and we are seeking opportunities to partner locally with the Chilean community, which has experienced a tremendous boost in their knowledge in astronomical technologies and in data mining techniques and so on. And I think this is a very good starting point for everyone. We also have an instrument development program where we develop through consortia of R&D institutes, mostly in our member states, but also elsewhere. And that is also a very good forum if you want to really get engaged on state-of-the-art technologies that are helpful in principle for astronomy, but also for other purposes. And we're also supporting this type of initiatives, which I think is the best way to engage the community internationally.
Thank you. And Dr. Kuch, would you agree? Do you see similar kinds of arrangements happening from your standpoint?
Yes, perhaps with a small difference. We are trying also to get support or to encourage these developing countries to get infrastructure and observations on the ground in their countries. And that's, I think, very important if you think, for example, on the global negotiations on climate change. They need to have their own observations, their own truth. And I think in particular, when it comes to adaptation to climate change, they need a lot of information about their ecosystems and about their agriculture, for example. So that's why we are really trying to support them in getting their perhaps adapted observational systems. And we have already finished a project together with African countries where we really tried to listen more than to tell them what they should do. And this listening was in a way also showing us that the perhaps high-tech approach that we have in the European countries is not always the best approach in developing countries, but it could be an interesting combination to get this information also on the ground there.
Oh, that's interesting. So adapting your infrastructure to the local context. I see you nodding there, Dr. Morris.
Yes, we have some good programs that we've been involved in, not as extensive as we would hope, but there's one in particular, which is an ecological education program that was commenced by some philanthropists in Korea to make it possible for people in underdeveloped countries first of all through Southeast Asia, but they're hoping to expand it, to go visit and carry out work at research infrastructure sites in more developed countries. And so in turn, we have 3 of our sites that have been appraised and are going into the catalogue of sites that students, both undergraduate and graduate students from Southeast Asia, can come learn how to do things, carry out some of their experiments using the infrastructure that wouldn't be available to them locally at this stage. We also have made our protocols available in quite a few different countries. So it means that anyone who is starting to develop some of their infrastructure doesn't have to start from zero. They can take a guide to how to do everything. And relatively recently, we sent a party of our people from Turn into Borneo, where they were setting up some flux towers, and we helped with the construction and provided all of the protocols that they would then be able to go on and continue operating it. So everything that we have, as Dr. Bacon said, is openly accessible around the world, and all of the data, just looking at our publications, there are some fabulous publications showing international collaborations from as many countries as you can count, because they're able to get data that allows them to look at things using what our infrastructure has collected and then reflect upon it at their local level, perhaps without such expensive equipment, but still make it useful.
You've touched on a few points there. One I want to pick up on, and that's the use of this type of infrastructure for outreach and training, outreach to the public in particular. And I'm wondering, Dr. Kutsch, are you involved in those kinds of initiatives as well, using the science, public outreach, education?
Well, we have a few projects. Perhaps I can mention one that we have just in a project that's under evaluation. So hopefully this will be coming, because I think this is a quite good example. We have recently submitted a proposal on urban observation. So we are measuring greenhouse gas emissions, but also the sinks by vegetation inside urban areas. And for this, you need a very dense sensor network. And in the proposal writing phase, we had the idea to put sensors on school buildings, so that they are part of our a network. So they are part of a scientific network, but they have their own sensor at the school. And I think this is an excellent way to get at least young citizens, students, young citizens involved into this kind of measurements. They could analyze the measurements in their science education, but also perhaps one could put CO2 sensors also for some time into the classroom and see a bit more about air quality in the classroom and so on and so on. So I think getting the normal infrastructure that we are using as scientists towards citizens, or in this case young citizens, I think that's a brilliant way to get the message into the society. And of course, we are also informing through various channels the general public on actual topics related to climate change and to greenhouse gases.
Thank you for that. And Dr. Barkan, do you find as well that increasingly, just it's important to be able to share information about this infrastructure with the public so they can understand the importance of these investments? Is that something that you're concerned with as well?
Yeah. I mean, in our case, this is even part of our mission to foster communication in astronomy. And therefore, we have quite comprehensive programs of, training people, studentships, fellowships in science, in engineering, internships. But we also develop quite a lot of work in outreach. We have school visits to our observatories. We do have a visitor center here in the headquarters in Garching. We have lots of online material and activities. We're doing guided tours through the internet now through our observatories. This is extremely important to maintain the engagement with society. I have to say that it may be by coincidence, but the panelists, we are all happy runners of infrastructures that are very inspiring to society for a variety of reasons. And that, I have to say, I'm very pleased with this. It's very easy to communicate our sciences, and we do it with a lot of pleasure. But there's also another aspect here that I want to mention, which is that for us, it's also an operational need. I mean, we need to train the new generations in skills that we can use, not only us, but infrastructures like ours will need in the future. And this is also an investment from our side. It's, of course, communication, but also investing in our own future.
Well, thank you for that. I'm conscious of the time that we have, that it's running down, and we do want to get to questions today. I really want to thank the panelists ever so much. You really have demonstrated the ways in which infrastructure partnerships need to be built. You've talked about the ways in which you're responding to the emerging crisis of climate change. You've talked about science, the funding of projects, and aspirations for the future. So this has been a great panel. I want to thank you for your comments today, and we'll move on to questions.